According to the National Electrical Code, a fixture whip is a flexible conduit used to connect a lighting fixture to a junction box or outlet box. Typically, it's made of a non-metallic material and serves as a substitute for rigid conduit when flexibility is necessary. If there are 6 fluorescent lights fed from a J-box with 1/2-inch flex, and then jump from light to light also with 1/2-inch flex, then all of that flex should be considered as fixture whips. Because in this particular instance, the 1/2-inch flex is being used to connect fluorescent lights to each other and to the J-box. This qualifies it as a fixture whip because it connects lighting fixtures to a junction box, is constructed from a flexible material, and is commonly non-metallic. The National Electrical Code, or NEC, provides guidelines for the safe installation of electrical wiring and equipment. Understanding these guidelines is crucial for any electrical installation, including lighting systems. When dealing with fluorescent lights and flexible conduit, it's important to determine if the conduit is acting as a fixture whip, because there are rules governing the use of fixture whips. These rules address factors such as the allowable length of the whip, the type of conduit permitted, and the proper methods for securing and supporting the whip. The purpose of these rules is to ensure that the electrical connections are mechanically sound and that the risk of electrical hazards, such as short circuits or ground faults, is minimized. When considering whether a section of flexible conduit qualifies as a fixture whip, firstly consider its purpose. If the conduit is used to connect a light fixture to a junction box, it is likely to be classified as a fixture whip. Secondly, evaluate its material. Fixture whips are often made of flexible, non-metallic materials to allow for easy positioning of the light fixture. Thirdly, assess its length. The NEC typically limits the maximum length of a fixture whip to a few feet to prevent excessive voltage drop and ensure proper circuit protection. Article 410.117 of the NEC covers the requirements for fixture whips and flexible cords. This section outlines the acceptable uses, materials, and installation practices for these types of connections. It's important to consult this article for specific requirements that apply to the electrical installation. In general, fixture whips should be installed in a neat and workmanlike manner. The conduit should be securely fastened to the junction box and the light fixture using appropriate connectors. The wires within the conduit should be properly insulated and sized according to the ampacity requirements of the circuit. Additionally, the fixture whip should be supported at intervals specified by the NEC to prevent sagging or strain on the connections. The NEC also addresses the use of grounding conductors within fixture whips. A grounding conductor is required to provide a low impedance path for fault current to return to the source, which helps to trip the circuit breaker or fuse in the event of a ground fault. The grounding conductor should be properly sized and connected to the grounding terminals in the junction box and the light fixture. Failure to properly ground the fixture whip can create a shock hazard. When installing fixture whips, it's important to be aware of any local codes or regulations that may supplement the NEC. Local jurisdictions may have additional requirements or restrictions on the use of flexible conduit or fixture whips. It's always best to consult with a local electrical inspector to ensure compliance with all applicable codes. In summary, when you are using flexible conduit to connect fluorescent lights to a junction box, you should consider it a fixture whip. This classification carries specific requirements under the NEC, including limitations on length, acceptable materials, and proper installation practices. By following these guidelines, you can ensure a safe and compliant electrical installation. Now let's delve a bit deeper into the specific requirements and considerations for fixture whips as defined by the National Electrical Code. Understanding these details is crucial for ensuring a safe and compliant electrical installation. Firstly, the allowable length of a fixture whip is a critical factor. The NEC typically limits the length of a fixture whip to a maximum of 6 feet. This limitation is in place to minimize voltage drop and to ensure that the circuit protection devices function properly in the event of a fault. Exceeding the allowable length can lead to overheating of the conductors and potential fire hazards. Secondly, the type of flexible conduit permitted for use as a fixture whip is also regulated. While various types of flexible conduit are available, The NEC specifies which types are suitable for use as fixture whips. Common types include flexible metal conduit or FMC, liquid type flexible metal conduit or LFMC, and flexible non-metallic conduit or FNMC. The choice of conduit depends on the specific application and environmental conditions. For example, LFMC is often used in damp or wet locations to prevent water from entering the conduit. Thirdly, the proper methods for securing and supporting fixture whips are essential for maintaining the integrity of the electrical connections. The NEC requires that fixture whips be securely fastened to the junction box and the light fixture using appropriate connectors. These connectors must be listed for use with the specific type of conduit being used. Additionally, the fixture whip should be supported at intervals specified by the NEC to prevent sagging or strain on the connections. The support requirements vary depending on the type and size of the conduit. Another important consideration is the ampacity of the conductors within the fixture whip. The ampacity refers to the maximum amount of current that a conductor can safely carry without overheating. The NEC provides tables that specify the ampacity of various types and sizes of conductors. When selecting conductors for a fixture whip, it's important to ensure that they have sufficient ampacity to handle the load of the light fixture. Overloading the conductors can lead to overheating and potential fire hazards. Furthermore, grounding conductors are a critical component of fixture whips. The NEC requires that all metal parts of an electrical system, including light fixtures and conduit, be properly grounded. The grounding conductor provides a low impedance path for fault current to return to the source, which helps to trip the circuit breaker or fuse in the event of a ground fault. The grounding conductor should be properly sized and connected to the grounding terminals in the junction box and the light fixture. Failure to properly ground the fixture whip can create a shock hazard. Now, let's discuss some common scenarios where fixture whips are used and how the NEC requirements apply to these situations. One common scenario is the installation of fluorescent lights in a commercial building. In this case, fixture whips are often used to connect the lights to the junction boxes in the ceiling. The NEC requires that the fixture whips be installed in accordance with all applicable requirements, including the length limitations, conduit type restrictions, and support requirements. Another scenario is the installation of lighting fixtures in a residential home. Fixture whips are often used to connect the lights to the outlet boxes in the walls or ceilings. The NEC requirements for fixture whips in residential installations are generally the same as those for commercial installations. However, there may be some differences in the local codes or regulations that apply to residential wiring. Now, let's address some frequently asked questions about fixture whips and the NEC. Firstly, can I use flexible metal conduit, or FMC, as a fixture whip? Yes, FMC is a commonly used type of flexible conduit for fixture whips. However, it's important to ensure that the FMC is properly sized and supported, and that it is connected to the junction box and the light fixture using appropriate connectors. Secondly, can I use liquid type flexible metal conduit, or LFMC, as a fixture whip? Yes, LFMC is often used in damp or wet locations to prevent water from entering the conduit. However, it's important to ensure that the LFMC is properly grounded and that it is connected to the junction box and the light fixture using appropriate connectors. Thirdly, can I use flexible non-metallic conduit, or FNMC, as a fixture whip? Yes, FNMC is a lightweight and flexible option for fixture whips. However, it's important to ensure that the FNMC is properly supported and that it is connected to the junction box and the light fixture using appropriate connectors. Fourthly, what is the maximum length of a fixture whip? The NEC typically limits the length of a fixture whip to a maximum of 6 feet. This limitation is in place to minimize voltage drop and to ensure that the circuit protection devices function properly in the event of a fault. Fifthly, do I need to ground the fixture whip? Yes, the NEC requires that all metal parts of an electrical system, including light fixtures and conduit, be properly grounded. The grounding conductor provides a low impedance path for fault current to return to the source, which helps to trip the circuit breaker or fuse in the event of a ground fault. In addition to these considerations, it is crucial to remember that electrical work can be dangerous. Always prioritize safety by firstly disconnecting the power supply before working on any electrical circuits. Secondly, using appropriate personal protective equipment such as safety glasses and gloves. Thirdly, consulting with a qualified electrician if you are unsure about any aspect of the electrical installation. Improper electrical work can lead to serious injury or even death. Therefore, it's essential to take the necessary precautions to protect yourself and others. The National Electrical Code is a comprehensive set of guidelines for the safe installation of electrical wiring and equipment. Understanding the NEC requirements for fixture whips is essential for ensuring a safe and compliant electrical installation. By following these guidelines, you can minimize the risk of electrical hazards and protect yourself and others from injury. Always consult the latest edition of the NEC and any applicable local codes or regulations before starting any electrical work. Electrical codes and standards are continuously updated to reflect new technologies, best practices, and safety concerns. Staying informed about these changes is crucial for ensuring that electrical installations are safe, efficient, and compliant. Remember that electrical work should only be performed by qualified individuals who have the necessary training and experience. If you are not comfortable working with electricity, it's best to hire a licensed electrician to perform the work. A qualified electrician will have the knowledge and skills to install electrical wiring and equipment safely and in accordance with all applicable codes. In conclusion, understanding fixture whips, the purpose, and the relevant NEC regulations is essential for anyone involved in electrical installations, particularly those dealing with lighting systems. By adhering to these guidelines, professionals and individuals alike can ensure safety, compliance, and optimal performance in their electrical projects. Always prioritize safety, stay informed about code updates, and seek professional assistance when needed to maintain a safe and reliable electrical environment.